Okay, it works. Yeah, hi everyone. Nice to meet you all. My name is Max, and I'm a co-founder of Arcane Finance. We're building privacy-centric decks on Aleo, and we decided to run a series of educational lectures that will help beginners to start building on Aleo. Yeah, so this is our site, and here we go. So let's start with just understanding why do we need one more blockchain. So there is a number of L1s and L2s, and well, what's the motivation behind creating one more chain? What makes it special? So the first point is privacy. Let's dig into how most blockchains work. Well, let's say like how Ethereum works. So there are public smart contracts that are published on the network, and also the data that is accessed by these smart contracts is public too. And then every node of the blockchain receives the same transaction and executes it, getting the same result, right? So by definition, now this model cannot be private by design, because every node has to execute the same code and like see the same values. And well, it means we need to have something different to make this private. Let's also discuss like what exactly we mean by privacy, because yeah, this is a really important thing. There are two types of privacy. There is a like weak privacy, pseudonymity, when well every user has a long-term consistent pseudonym. Let's say Ethereum address. So by looking on chain, people cannot see your surname, but they will see the same address again and again. And well, it is inevitable that, well, at least the probability is high that your real-world identity can leak over time. For example, you can interact with a certain thing that requires KYC, and yeah, this thing will know your your identity, and will link it to this address and probably to some other addresses that also like interact with the same addresses. So there are some like ways to extract data from on-chain storage and analyze it in a way to like figure out now that a number of addresses belong to a single person. Like there are some heuristics existing for Bitcoin and from Ethereum too. And that's why what we're seeking is like full anonymity, like strong privacy, so that like users' transactions are unlinkable. We cannot say like that this transaction kind of was initiated by this user and like modifies their data. It's like totally private. And well, this is something that is not solved by default by Ethereum and Bitcoin and most of the other chains. And well, again, let's reiterate. So chains like Ethereum and Bitcoin provide no privacy in a strong sense of this word. Some solutions provide, well, like, I mean, most centralized solutions provide privacy from public, but like certain organization and like certain governments and certain entities can have access to your data, but it's private from public, from regular person, from your friends, let's say. But we are looking at like full privacy. On Ethereum, full privacy is implemented by Tornado Cash. and like some blockchains like Monero have this, and also Aleo uh, is one of the chain that solves this problem. So it allows to create fully private transactions. Yeah, so let's speak why privacy is important. Some people might say, hey, I'm using like Ethereum on a daily basis and I'm fine doing that, like no one knows what I do and stuff like that. Let's consider several use cases. It can be like medical data management. So let's say we want to store patient medical data on chain, and like so that only authorized entities have access to these data. Well, I believe it's pretty obvious that like if there is no privacy, patient confidentiality will be broken, like no medical history security, like legal ethical compliance, and like all kind of things like that will be broken. And well, the same remains true for financial transactions. So imagine like you're spending your money both online and offline using crypto. And in this case, if you come to a certain merchant, to a grocery store, to a coffee shop, and like purchase something, a merchant will know that like you own this address, and they can see like how much money you have. And well, this opens you up to a number of like scams and all kinds of crimes. And well, the third use case is supply chain management. So imagine like a company organizes like production facility, and it has to buy something from different suppliers, and they can do this on chain. But it means their competitors will see like what's going on chain. They will see what's happening and can use this information to yeah to do some damage to the company that organizes that. This means that the absence of privacy actually prevents us from implementing a number of very important use cases for Web3, and especially like using Web3 in the real world. Well, I mean, like in real world, everyone expects that their transactions are at least private from public, like in the case of payment systems. So yeah, let's imagine that we could do private computations, but still be able to prove on chain that they are correct, right? And by computations, I mean like not only stateless computations, but you can also store some data in this computation. So you can do some private computation, store some data, and no one is able to see this data on chain, though it's stored there. And also everyone knows, as it's done by cryptography, that all the computations that were conducted are correct, and they correspond to the rules of the network itself. And well, another reason why we need one more blockchain, why we need Aleo, is the limited computation capacity of traditional smart contract systems. So there are like two parts of that, like limited resources and excessive computation. So about limited resources, I mean like that, Ethereum, I remember this. Ethereum has a limit, has a gas limit for its transaction, and well, in case of Ethereum, it will be for us very expensive. But even if it was not that expensive, actually there are a lot of tasks that cannot be solved inside smart contract because it has limited resources. So if you have like a supercomputer that can run for a day to like build some neural network, like build some AI model, well, you cannot do anything similar on chain in a smart contract, as it just does not allow you to do that. And another thing is excessive computation. So there is a small example. So let's say our imagine network has 1,000 nodes, and each block takes 10 seconds to calculate. It means that like every node will be essentially like calculating the same thing 1,000 times. So like in total, I mean, this will lead to like incredible amount of self-repeating computation. So it take over 2.5 hours to calculate something that should ideally take 10 seconds to calculate. So this is another motivation for having another network that allows doing that. And well, L2s are trying to solve the same problems actually. So they are trying to move computation off chain. Well, but Aleo is different. Aleo is a L1 chain. And yeah, so again, let's imagine that we could do complex off-chain computations, but still be able to prove on-chain that they are correct. So is there a magic that can make our off-chain computations both private and complex? Yeah, so it seems there is a positive answer to this question, and this answer is Aleo. And yeah, let's see how it manages to do that. So the magic that works under the hood is zero-knowledge proofs. Essentially, well, I won't go deep into what is ZK and like trying to formally define what it is. And well, there is a number of very good lecturers that are doing that. I won't go deep into ZK. I will just try to explain what it is. So basically, zero knowledge proof allows you to prove that you know something is true without saying what that thing is. So you can, for example, let's take some real world example. Let's say you want to prove that you are over 18 years old, but you don't want to say what's your exact age. Something like zero knowledge proof could help you doing that. I mean, in a blockchain system. So yeah, it's like for now, let's say it's a special way of proving things without giving away all the details. For Aleo case, well, it might be some like computation that was done off chain, and now we can prove that it was done correctly on chain by providing a small thing that's called like proof commitment. Yeah, for now, let's say that's it. But well, we'll definitely go deeper into ZK in the next lections. So let's see where Aleo is with regards to other blockchains. So there is a matrix that shows 4 chains. Right, so let's start from the very first chain, which was Bitcoin. Bitcoin is, as we discussed before, is non-private, it's public, and it's non-programmable generally. So there are no smart contracts on Bitcoin. That's why it's residing on the bottom level corner. The next iterations were Ethereum, which added programmability to the blockchain, and yeah, but again, it doesn't add privacy. And Zcash was a blockchain that added privacy, but didn't add programmability. And finally, Aleo is here. So they are like taking best of both worlds and are combining both programmability and privacy into one chain. Yeah, let's briefly go through different models that are used by different chains to better understand how Aleo works. So Bitcoin uses UTXO model, which means unspent transactions. UTX stands for unspent transaction. And well, it means that there are some transactions from one wallet to another, from one address to another, and the total amount of money that you have is the sum of all the unspent transactions that you have access to, essentially. So there is no thing such as account in Bitcoin. There are only transactions and unspent outputs in these transactions. This is how Bitcoin works. And Ethereum is pretty different. So it has a notion of account. So your account, your address owns something, or has some Ethereum Ether balance in it. And well, it's combined from all the transactions automatically. So it belongs to your address. So these are essentially two models of organizing blockchains. And well, let's see how Aleo compares to that. So Aleo has again tries to take best from the both worlds. So account, Aleo does have account, but at the same time it has record, which is more similar to UTXO. So account is like something, I'd say, yeah, it's pretty similar to what Ethereum has. So account is your address plus your public key. Well, address and public key is more or less the same. Also your view key and your private key. Like private key allows you to generate transactions, and view key allows you to see encrypted data in your account. This is like a Leo specific thing. And also there are records. So records are stored. Let's see on the records on this slide. Yeah, so each record has an owner, has a certain amount of credits, which is a native Aleo currency, similar to Ether on Ethereum. So Aleo records have microcredits, some arbitrary data, and can be either private or public. Yeah, for us, as we discussed privacy before, like private records are more interesting. So yeah, there are these records, and private records are fully encrypted on chain. So they are encrypted with the key of the owner. So owner is the only person who can decrypt the record. Their record. Yeah, so and each record is stored independently, which makes them more similar to Bitcoin storage model. So they are not linked to account. Yeah, and well, each record, well, going back and forth, each record. So smart contracts are programs on Aleo, and yeah, so each program has a number of functions that are called transitions, and transitions can consume records and create new records. Also, transitions are included in transactions, and transactions are included in blocks. So this is essentially how Aleo works. So it, yeah, just to highlight, yeah, so the state of a user account is actually a set of unspent records belonging to the account. This makes it really similar to UTXO. And yeah, so there are like two ways to store data in Aleo. You can either use records, which I mentioned before, and they can be either private or public, and they can be accessed, they can be created and consumed by off-chain programs. Off-chain programs are off-chain part of a programs, and there are also mappings that are stored on-chain, so that they are always public, and they can be yeah, they can be read by Aleo API. And program mappings are always public. They can be accessed by on-chain code. So here we approach the dual character of Aleo. So it has both off-chain part and on-chain part. So off-chain part is represented by records, storage, and on-chain part is represented by program mappings. Yeah. Okay. Also, I wanted to mention that essentially each transition on Aleo can have both private off-chain part and public on-chain part. And the private on-chain part is actually executed on your computer, as you might have mentioned. Is noticed if you used Aleo before, well, it takes some time to generate transaction. Well, yeah, it means that wallet executes private part of the smart contract off chain and then submits proof to the on-chain part. Yeah, now we can briefly take a look at how this works in practice. Yeah, let's see how it works. Okay. Yeah. I'm unlocking. I'm unlocking my Aleo wallet, and here I can go to faucet and yeah, let's try and get some test tokens just as an example of transaction. Yeah, I hope actually that that my screen is visible, that you can see my wallet. I'm not totally sure. Okay, it seems you cannot see my wallet, which is sad. Let me try. Okay, I will reshare it so that you can see the wallet and what's going on inside the wallet. Yeah. So let's say I want to claim 5 USDT in Arcane private faucet. So I press claim, and here is a Aleo wallet confirmation. It asks me to confirm that I'm executing mint private function on a certain program, or an Arcane Finance program that was deployed on chain with the following inputs. So certain fee. I think I haven't mentioned that, but fee is required. So fee is essentially the same as gas in other chains. And you see some arguments that are passed to this function, and yeah. So basically, you can see inputs. Now I'm confirming these transactions. So here we can see, yeah, actually it's the second transaction I'm running for this program. That's why it does not, we are skipping the step of downloading proving files. Well, if it was the first interaction, the program would have to download prover files to be able to generate off-chain proofs for the transaction. Yeah, so generating transaction means that the proof is being generated locally, so nothing is sent on-chain so far. Well, it takes some time. Okay. Yeah. So now the transaction is being executed. This part is public. Yeah, like submitted on chain. It's not public actually. It's just submitted on chain. And well, let's see how it works. yeah, actually, we are. That's more or less it for today. We decided to keep lectures pretty short and digestible, and well, it would be amazing to get your guys' feedback on like what you liked and like what topics should be covered in more detail. Yeah. Well, okay, let's see whether it worked. Okay, confirm. Okay, yeah, we see that my balance updated, which means the transaction worked fine. Okay, I think that's it. So thanks a lot for your time, guys, and well, see you.